In the previous 4 episodes in this mini-series, we came up with a working implementation of a very small subset of the Unix tail command. The code we wound up with is reasonably compact. It's also very reminiscent of C code. If you went and looked at the source for the GNU implementation of tail, you'd find code that looked pretty similar. Aspects like the nesting of loops and the long do-while loop with a complex condition at the very end are characteristic of Unix C source code. It's nice that we can write C in Ruby if we want to, but that's not why we use the language. When we write idiomatic Ruby, we use things like blocks and small methods with meaningful names to produce code that reads almost like a narrative description of the solution. Let's see if we can apply a little Ruby sugar to this code to make it read better than it does, at least at the top level. First, that big do-while loop, implemented as a begin-end block with a while condition on the end, is a major obstacle to comprehending this code. It's nice that we know how to make a do-while loop in Ruby now, but there's a reason we don't see a lot of this kind of loop in idiomatic Ruby code. It's not a very readable construct. We have to get all the way to the end of the loop body before we discover just what condition the loop has been looping on. We'll start by extracting this loop out into a method of its own. We copy the entire loop and paste it into a new method named eachChunk. The method will take one argument, file, which is the file object to read from. We also pull the chunk size and next chunk offset variables into this method. Inside the loop body, we replace the inner loop with a yield statement, yielding the current chunk to the block given to this method. This loop is strictly focused on iterating over chunks. It has no knowledge of new lines, so we remove the new line count part of the loop condition. Finally, we return an empty string from the method. The reason for this will become clear later. Back in the main code, we replace the outer loop with a call to each chunk, passing in the opened file. We capture the result of the call in a variable called startText. We get rid of all the lines having to do with file seeking and reading. The inner loop remains the same. The reason we capture startText is because now that we're processing chunks in a block, both the chunk variable and the nlindex variable are local to that block, so we can no longer use these variables once the loops are finished. Instead, we add a line that breaks out of the loop with an explicit value when sufficient new lines are found. The value is the part of the current text chunk that contains the 10th to last line and onward. This is also why each chunk returns an empty string by default, so that in the case where enough new lines are never found, this code will still capture a string value. Now that we are producing the starting text within the loop code, we can simplify the line that prints this text out. Now we turn our attention to the inner loop. Once again, we copy the code and paste it into a new method. This method is named eachReverseNewLineIndex. It receives a chunk of text as its sole argument. We keep the loop itself as is, but we replace the body, as before, with a yield. This time we yield the found new line index. We also return the last found new line index from this method once the loop finishes. In the main code, we replace the loop with a method invocation, passing in the current chunk. We keep the old loop body inside the block with one modification. If and when sufficient new lines are found, we break with an explicit value, the last new line index. Once again, this lets us use the return value of the method to get at a block internal value once the method is finished. There are more refactorings we could do to this code. For one thing, we've only papered over that nasty do-while loop by hiding it away in a method. Anyone who modifies the code is still going to have to contend with it. And there's something a little fishy about having two separate but similar break statements, each checking the new line count. But on the other hand, we've made the main code more intention-revealing by using semantically named methods. It is now clear, even without comments, that this code has an outer loop that loops over chunks of text from a file, and an inner loop that looks for new line indices in a given chunk. And I think that's enough for today. Happy hacking!